So welcome everyone to the JKMRC Friday Seminar for Friday the 27th of August. You're good. My name is Nathan Fox from W.H. Bryan Mining and Geology Research Centre here at the Sustainable Minerals Institute. Just before we begin today, the University of Queensland would like to acknowledge the traditional owners of the lands, and custodianships of the lands we meet today. We pay our respects to their ancestors and to their descendants who continue cultural and spiritual connections to country. We recognise their valuable contributions to Australian and global society. So today's speaker, it's a real pleasure to introduce Dan. We've had a few delays due to COVID, but it's really nice to have Dan here today with us. Most of you will obviously know Dan, but here, by way of background, fundamentally Dan is an exploration geologist. He has more than 40 years experience in exploration, including 24 years with BHP and a further 18 years with Newcrest. After retiring from commercial exploration in 2008, Dan's continued to work in the mineral sector, and he's held roles in academia, including here at the BRC as a director of the Bryan Research Centre. Just going back to Dan's sort of beginnings, he started out with BHP working on a range of commodities, including early exploration for oil shales before moving on to copper and gold. Significantly, and the focus of today's talk, in the mid-90s, Dan led the exploration team in Newcrest as the executive general manager of exploration. And this was an exploration group that was consistently ranked as the world's most successful gold explorer by the Metals Economic Group of Canada, which is an interesting fact I didn't know. But it was this discovery team that led to the exploration discovery of the world-class porphyry copper mineralisation at Cadia. And this is Australia's premier porphyry system. It's a system that has been well researched both here at the JKMRC and by other groups in Australia. So it's really good to actually have Dan here today to talk about the discovery of this important system. Dan's talk is going to be really talking about exploration methods used by the Newcrest team, and I think it's really significant for us to understand the discovery of this system, because if we want to find new systems similar to this, we certainly need to apply the similar tools, but also out-of-the-box thinking. I think it's going to be really good to have Dan talking us through this. So Dan's talk, Chancing One's Arm, Discovery of the Cadia District. Over to you. For those of you online, if you can please type questions towards the end in the question and answer box. But for now, Dan, the floor is yours. Thank you. It works.
Okay, well, thank you very much for having me. As Nathan said, I want to talk about chancing one's arm, and I've got some dice and that up there. So it's a bit about gambling. That's what this talk's about. Oops, wrong way. So what I want to do is this is a long talk. I want to take you through the history of Newcrest Mining. I want to then take you through these 4 discoveries and then give you some concluding comments. Now, as I start to work through these, you're going to start to look at me and think, he's having me on, and because they become more and more less believable as I go on. So anyway, the real key to the Newcrest discoveries at Cadia was really this quote by William Hazlitt, who was an English essayist. And he said, "I'm not smart, but I like to observe. Millions saw the apple fall, but Newton was the one who asked why." That's really important. The problem, though, with exploration is the question isn't why. The question is what if, and where. That's what you're on about. It's not why, it's what if and where. And that's where you run into trouble with the academic approach to exploration. It's about the why rather than the what if and where. So what is discovery and mineral exploration? Well, it's a random and rare event. It's an outcome of a really chaotic process. So if you're a linear thinker, it doesn't work, and it really comes about because of non-linear thinking. So if you're trained as an engineer, you're going to have a bit of trouble as an exploration geologist. Now, I like this. Mineral exploration, there's a chap called Schlichter, who was a geophysicist in 1960. He gave the Jacqueline lecture. And he said mineral exploration is the world's biggest and best gambling business. And that's what it is. But there's a point to it that he made. The attractive feature of this gamble is that the players are free to rig the odds as favourably as possible. And that's the key. You've got to rig the odds. You're in the casino and you're cheating. You're rigging the odds. So Cadia gamble paid off handsomely for Newcrest. And these are the two gentlemen that were responsible for it. This one is John Quinn. He was the CEO, the first CEO of Newcrest. He was an accountant, but he really was a frustrated exploration geologist. And we took him places that you couldn't take a CEO these days. The other person here is John Holliday, who trained first as an economist, then he trained as a geophysicist. He's probably one of the best geologists, exploration geologists I know. So what was the gamble for Newcrest? Well, when we were formed in the end of 1990 or 91, we were worth less than $200 million. So we spent $38 million to discover the Cadia Hill deposit. We borrowed $400 million to build a $440 million mine to mine this Cadia Hill deposit. And what Cadia Hill was a very low-grade gold copper that the experts, all the experts in Australia, expected to fail. And it was going to fail because of its size and grade. What the experts failed to understand was that Cadia Hill, the Cadia Hill gold copper deposit was really a high-grade gold was really a high-grade copper deposit with a low waste-to-ore ratio. So it wasn't a gold deposit, it was a copper deposit. It just happened to have more gold than copper. It was located adjacent to a city of 30,000 people, 20 minutes away. It was a 4-hour drive west of Sydney, and that's how the rigs were on. The odds were rigged because of those features. So the Newcrest story, in mid-1986, BHP had an offshoot called BHP Gold, as most of the major mining companies had in those days. And BHP Gold bought Browns Creek Mine, which is in the Cadia district. In 1986, Browns Creek Mine was running out of ore, so it wasn't a very good purchase. The big Cadia deposits at Cadia in New South Wales were a possible ore source. They were owned by Alan Bond. In March 1987, BHP Gold Mine was formed by BHP. They spun off their gold arm, as North did with Nor Gold. All the big companies spun off their arms. In 1990, Newmont Australia was under a corporate attack by Robert de Crespigny because they didn't get on, let's put it that way. So in December 1990, BHP Gold and Newmont Australia decided to merge. BHP and Newmont America went back to the 1930s. So BHP became the white knight for BHP, for Newmont Australia. So the big Cadia acquisition started in 1986. It was completed in March 1991. So it took a fair while. And that was also a key to Newcrest's success. So he formed the company at the end of 1990, December 1990. In August 1991, John Quinn decided we better have a strategy meeting. So we had a strategy meeting, and the exploration team was told to discover 2 million ounces of gold in 3 years. Otherwise, the company was out of business. So, yeah. Pressure has some effects in life. This is a map. Tom O'Driscoll was work with Roy Woodall from Western mining days. And when I went through university in the 1960s, linear features on maps had significance. I believe they still have significance. So anyway, Driscoll put together a map of, well, the world, but he put together a map of Australia with a whole lot of linear, straight lines on it. He had one straight line, which was numbered 3, and that was a corridor that in 1987 we were looking at in BHP gold as being of interest to us. This is a corridor that we used in Newcrest to discover the Cracker gold shoots up north of Brisbane. And this just shows you, that's that corridor there. This is the corridor that Roy Woodall and Driscoll used to find the Olympic Dam deposit in South Australia. Now this just shows you the regional magnetics of that part of the world through in New South Wales. Shows the corridor through here. And I'll show you in a bit more detail as it goes through. That, so that's that corridor running through here. This is where Cadia is in relation to Sydney and to Orange and to Bathurst, and there's a railway line through here into Blaney. So that's the corridor that the BHP gold geologists were interested in. This is what's called the Ganumbla Linear. And Ganumbla, or North Pass, was the first porphyry copper gold deposit discovered in Australia by Paul Heatherstone Company with Geopico, and there's a straight line that runs through North Ganumbla, Cadia, and you can see it on all sorts of maps. This is another linear that Newcrest used in the late 1990s to discover another porphyry called Marsden that's under 100 metres of transported cover. So this is back to this aeromagnetic map of New South Wales with this corridor through here. And you can see not all the colours in the corridor are the same. There's blues and reds and yellows. This is the Cadia district, which is this district, which is this district. And you can see this trend of the corridor runs through here. This is the Cadia deposits. This is a magnetic complex that's through here. And this is based on helimagnetics that Newcrest did. Just flies around the helicopter about 15 metres above the land surface. So we were told we had to find 2 million ounces in 3 years. So this is the goal starting in 1991. Well, 1992 really. So this is a goal that was added by February 1994, 3 million, September 94, 4.5 million, April 95, 6.5. The total endowment, according to Alan Wilson at the moment, of the Cadia district is around about 86 million ounces of gold equivalent. And the target was 2 million ounces. Now this is Alan's, Alan did his PhD. He did the first PhD on the Cadia district in 2003. So this just shows you where the deposits are and their sizes. So Ridgeway's about 11 million ounces, Cadia Quarry's about 1 million, Cadia Hill, which was the original, was 12 million. This Katiereese, which is Katiereese and Far East, is about 62 million ounces of gold. And that's how you get that endowment. This is the big Cadia deposit, and the reason the Newcrest was there. Just to put that in context, Victoria has produced about 77 million ounces of gold. Now, that's 32% of Australia's gold production. Now, I don't know what Cadia is going to produce over the next 50 years, but say they produce 50 million ounces of gold equivalent. If they recovered 57% of that, they produce 50 million ounces, which is 2/3 of what Victoria produced from 1851 onwards. Now, all the Newcrest geologists did was look at old data and then follow up the old data. So, so this is the drilling at Cadia prior to the Newcrest discoveries. These are the deposits. These black spots are all the drill holes that were drilled in that area prior to Newcrest coming along. Now, that's big Cadia, this is little Cadia. What is interesting is that there's holes that fit within where these deposits are. So one of the companies that was there from the 1960s onward was a Canadian company called Pacific Copper. And this is their drilling from 1968 onwards around the Cadia Hill, the Cadia Quarry and the Katiereese area. So these are the holes that they drilled. So you can see they drilled a few holes close to the deposit. Now what is interesting is, and this is all in the database, this is all available in the public record. So this is the average copper value in their holes. So yellow is 0.1 to 0.3% copper, blue is less than 0.1. Now, the interesting numbers are the yellow ones. And this one, say 0.2 copper, if you had a porphyry copper deposit, is actually cut-off grade for a porphyry copper deposit. So these values here and that value there, they're low-grade ore values if there was an ore deposit there. You had to find the ore deposit, but if it was there, they may be within your pit. Now, if you look at their gold results, so 0.1 to gram, greater than gram, these values here were definitely ore grade if there was an ore deposit around. And you can see where they drilled them, on the edge of the pit. These values are all less than cut-off grade for gold. But the interesting thing is if you stop thinking about it as it may be a gold deposit or a copper deposit, to think of it as a copper equivalent or a copper deposit, these are what these values become. So 0.1 to 0.5, 0.5 to 1, greater than 1. So there's a 0.5 over here, there's a 0.2 there, there's a 1, there's a 0.6, 0.7. Now, there's two reasons why this area was of porphyry copper interest to us as gold explorers. One was the copper equivalent grade, and the other was the scale, that's a kilometre. Now, the typical porphyry mine cut-off grade is 0.2% copper. So what you're presented with before you start exploring is, in respect of Cadia Hill, is ore-grade material, if you could find the ore deposit, a distance that's over 1.5 kilometres between there and this value over here. And what are you going to do about it? So the estimated mineral resources at Cadia are Cadia Hill, 9.5 million ounces of gold, nearly 1 million tonnes of copper, Ridgeway, 7 and 1. Cadia Quarry was a bit of a squib. And then Katiereese, 38 million ounces of gold, 8 million tonnes of copper. So ringing the odds. Well, first off, don't call it gold exploration. For the Newcrest board, the target was dollars, and the dollar was $20. We were looking for $20 rock. And that's how I sold the deposit to the exploration of the Newcrest board. Forget about metals, copper and gold, just think in terms of dollars. For mining analysts, the target was copper equivalent. And we were looking for a porphyry copper deposit, except it happened to be a gold deposit, but it really was a copper deposit. So we required some alchemy, and all we needed was a formula. So this is the discovery hole for Cadia Hill, NC40. These are the gold grades, these are the copper grades, but if you do the alchemy, this is the copper equivalent grade. And you can see if you're looking at a copper equivalent cutoff of 0.2% copper, that hole is all ore grade. So this is Cadia Hill in 1993, this hill here. This is all secondary forest that had all been cleared by the miners that have been there since 1850. There were two pine forests. There was a commercial pine forest here. And there was a little old lady called Mrs. Marr, and she hadn't looked after a pine forest, and that was really run down. The problem was Mrs. Marr didn't like geologists, and she wouldn't let a lot of geologists into the property. This is the general geology of the Cadia district. All this material here is younger cover material. These are the Ordovician intrusions, and that's the age of the Cadia mineralisation, somewhere around about the 440 million years. What is interesting about this recent cover is it includes 10 centimetres of wind-blown ash, of wind-blown soil dust that probably came from Central Australia. Australia has a lot of wind-blown dust on it. So if you're doing soil geochemistry, you want to think about wind-blown dust. The cover material at Cadia, this is Cadia Hill, was a real advantage because it was previously misunderstood. The homestake people thought the Silurian was potentially mineralised, whereas it was post-mineral. Nobody knew what was transported in the residual because it was all pine forest and you couldn't see anything. The mapping that the Newcrest geologists did was looking at the roots of pine trees that had fallen over and mapping the rocks and the roots of the trees because you couldn't see any outcrop. So what we had in regard to values was we worked out that these pale grade areas were probably residual soils. All the rest of it was transported soils. This material was 300 odd million years old, cover material. But we had a 0.5 gram gold number there, a 1 gram gold number there, and we had an old open cut, the old timers in mind. And that meant that, we could probably believe these values, and we can certainly believe the values that Newcrest found around the old open cut. This is the old open cut. It measured 89 metres if you taped around the bottom of it. We had geologists and field assistants in with shovels and spades and hoses, and we spaded down all these faces, and then we channel sampled along it. We got 89 metres of a gram of gold and just over 0.2% copper. But what it showed us was that the mineralisation was contained in a preferred orientation. There were sheeted veins. There's a whole lot of sheeted veins. They dipped about 45 degrees of southwest and they had a northwest strike. This is Mrs. Marr's rundown pine forest. So these are the previous gold results in the area, soil results. And, there's a 0.5 gram gold. This is 100 metres. And they clearly identified a coherent area of elevated soil values. And it was open in this direction. This is where the open cut's at. These are the RAB drilling by Pacific Copper and Homestake in the area. And you can see the RAB holes, same thing, fitted within the soil anomaly. So they supported their soil results. And this is the previous core and RC percussion drilling. And there's a number of holes. They're going all over the place and they're quite tightly confined. But, 97 metres of 0.9%, 9 grams per tonne gold. That was all grade if you could find a gold deposit, except it was really a copper deposit. And so all of this drilling supported all the previous geochemistry. So this is just one example. That's the 96 metres of 0.6 on here, which is this one up here. So you can see the values are up and down, but it averages 96 metres of 0.6% grams per tonne gold. And again, it's ore if you could find the ore deposit. So before we did anything, this is what we started with. So we had the Silurian that we'd worked out was probably older than any mineralisation. We had a window here that we thought was a mixture of transported and residual soils. We had those values, we had this drilling, and what was crucial was to know that whether you were sampling residual soils or not. We decided that people didn't know what they were sampling, and the only way to sample was using auger, hand auger, to get down to the sea horizon in the soils, and that's what we did. When that was done, these are these two values here. This is a 0.4 grams per tonne gold soil value. This is the open cut. So most of the soils here weren't residual, they were transported. Now, this is crucial. The topography was crucial in terms of how you interpreted the soil geochemistry. What you had to do was lay the soil geochemistry on top of the topography and visualise what you were seeing. And once you did that, it became apparent that what you were looking at with this shape on this topography was a slab that was trending in this direction, was maybe 150 metres thick, and it was dipping to the southwest at about 45 degrees. See, on the basis of that, we then constructed open pits. We drew open pits, and for 50 million tonnes, 100 million tonnes, 150 million tonnes, different waste to ore ratios, and was something that was 150 metres wide. Turned out it was 250 metres wide. So all they did was change the tonnages. So that conceptual thinking, and this is what this whole talk comes back about to, is about thinking, was how all the drilling was planned. So we planned the drilling to drill at least 50 metres into the wall rock, the waste rock of the open pit. And that was used to plan all the drilling. Before we could drill, we had to buy the pine forest. Fortunately, Alan Bond, Mrs. Ma had died, an insurance company had bought the pine forest and they did a deal. And so it was built. What was interesting about this was the contractor who did this drilling name was Tom, T-H-O-M, and he was related to the field assistant that was with Hargraves when he discovered gold at Lewis Ponds. And Hargrave was at Cadia in 1851 at the time the chief government geologist was at Cadia at the time that Hargrave discovered gold 30 miles away from Cadia. And the news came to Stutchbury. He was a geologist at Cadia. He got on his horse and he rode off to Lewis Ponds, but he was at Cadia before he went to Lewis Ponds. So these are the first 6 holes that were drilled by Newcrest, NC 35 to 40. NC we use that system because Pacific Copper had used an NC system. So NC 40 was a discovery hole. These are the first 6 holes. Now, this is NC 41. NC 40, the target was average rock of $20 a tonne. It averaged $21.50. So the Newcrest board was happy. They had the $20 rock. Our cut-off grade was $10 rock. This is what the Katie Hill sheeted veins look like. The average grade of those 10 metres is nearly 1.5 grams and 0.1 copper, which is about 1.3% copper equivalent. It's in a quartz monzonite porphyry, but it's not. The quartz monzonite porphyry isn't the mineralizer to these veins. So this is the section with the NC40 hole on it. You can see the hole average. This is gold values, averaged 1.2 grams per tonne over 240 metres. This was 250 metres of 1.5. I put up here the copper equivalent values. So this hole here, NC40, was 301 metres of 1% copper equivalent. This hole here was 0.72% copper equivalent. This hole here was 460 metres of 0.7% copper equivalent. So for someone seeking to discover a porphyry copper deposit, these are fairly high-grade copper results and long drill intercepts. So this was the final pit design. that closely followed the original discovery pit design. And these are the intersects with gold. This is just a schematic showing the distribution of different copper sulfide minerals and some alteration. Now, the copper sulfide mineral zoning at Cadia Hill doesn't fit what people think is a standard model for a porphyry copper deposit. Nothing we ever did at Cadia was standard. We didn't believe anything. And so we built our own model by observing and recording and disregarding the standard model. Yeah, most of the mineral, this is a 1 gram per tonne gold envelope. This is a 0.5 gram per tonne. So most of it sits within chalcopyrite type mineralisation. This is pyrite magnetite. This is bornite chalcopyrite, and this hematite up here. So I just thought I'd put this up for posterity. This is the discovery and feasibility study officers. This is what the metallurgists and engineers had. This is what the geologists had, and it was later condemned. So discovery of the Katiereese deposit. Katiereese, which sits here, was discovered along trend from Cadia Hill. It's not part of the Cadia Hill deposit. So this is the Cadia Hill pit boundary through here. The discovery hole for Katiereese was NC 107. It recorded 145 metres of 0.5 gold and 0.3% copper from 232 metres. This is an interesting hole because it started in this green material, which is forest reef volcanics, which wasn't mineralised. It went through a fault into the Silurian, went through the Silurian, through an unconformity in the fault, back into the forest reef volcanics, which is where the mineralisation was lurking. To decide where to drill those holes, all we did was said, well, that's the trend, let's drill down there. And that's what happened. So this is a Katiereese deposit. It has a high-grade zone here. There's more than 2 grams per tonne gold equivalent, and a large volume of 1 grams per tonne gold equivalent. This is 500 metres. What is interesting, this is the purple is a Silurian cover. This is essentially unaltered, well, was unmineralised forest reef volcanics. This is greater, the yellow is greater than 0.3% grams per tonne gold. What is interesting on here is this red line, which is the top of a vein zone, this blue line, which is the top of a bornite zone. The mineralisation up here is disseminated. The mineralisation through here is disseminated, impacted by veins. So this is the alteration there. So Silurian, basically unaltered volcanics, potassic, what is phyllic, and what is propilytic. Phyllic is quartz-sericite pyrite, propilytic is chlorite, and potassic is either secondary biotite or K-feldspar. But in this case, we've got albitic alteration. So the vein zone was present in the propilytic, the phyllic, and the potassic alteration, which is interesting. But we didn't know what was going on down through there. So the mineral resource for Katiereese was estimated in late 1995 to be nearly 2 million ounces of gold. Now, it eventually became a bit over 4.5 million ounces of gold and 1 million tonnes of copper, and it was a potential open pit deposit. The problem was, with Cadia Hill, we were betting the company on a low-grade gold deposit, or a high-grade copper deposit or a low-grade gold deposit, wherever you go. And higher grade would help. It would certainly help the board. They were a bit worried about the gold grade. Katiereese wouldn't add grade. So we redirected the search under basalt cover to the northwest. So this is where Katiereese sits. This is where Cadia Hill sits. This is Cadia Quarry. That area there has barren rocks with no recorded gold or copper. This orange area is the tertiary basalt. That's the trend. So the trend said, look up here, young man, and that's where he went. What is interesting on this that nobody's really ever focused on much is the trend of the dikes. The trend of the dikes is the same as the trend of the mineralisation. And what I believe is quite important is those dikes are alkaline intrusions. So I'll just get into a bit of arm waving for a minute. Pattern recognition and mineral alteration. If you're doing an IQ test, you'll be given something like this with a blank square and you said, what's the answer? And it's pretty simple to work it out. In exploration, it's not quite that simple. You're given one square on a blank piece of paper, you're given a square down here and a question mark in it, and no clues like you got here, and they ask you what is there. So in an IQ test, well, the possibilities were those, and it's quite simple to work it out. In exploration, the pattern possibility may not be obvious, and the answer wasn't an option in the IQ test, because the answer to what is there wasn't what would come out of that. It's that. So, and that's why exploration doesn't behave the way it should. This may sound really complicated. It's not. What I'm trying to say is don't expect to see what you expect to see, because it obviously often isn't what is there really there. So discovery of the Ridgeway Deposit. So we found Cadia Hill down here, Katiereese down here. We decided that IP was probably useful to use. So these are the IP traverses that were done. There were two traverses done over Cadia Hill and Katiereese. Katiereese was under 200 metres of cover. So we worked out with a 200-metre dipole, we could detect Cadia Hill quite easily, and we could detect Katiereese under 200 metres of cover. So the area of interest was the area up here. These are all the IP traverses. The one that went across here that interested us was this one down here. You're always in trouble with IP because you never know what to select. So you never select the best looking, or you need to select and test a number of possibilities. In this case, we tested the worst one on offer and turned out to be the best one on offer. So this is the IP over Ridgeway. Ridgeway sits here. This is the IP effect. This is chargeability. Don't disregard that. That has to do with the another geological unit called the Weimar. Now, the IP system we use, because Ridgeway, the top of Ridgeway is 500 metres down, we didn't actually detect Ridgeway. What we detected was the alteration halo to Ridgeway, which had pyrite in it. So that's all that's showing you, is there is pyrite around the Ridgeway deposit. So we tested the IP by running two traverses of holes 200 metres apart. They were RC percussion holes 200 metres apart. Only one hole recorded gold and copper values. And it was the first hole we drilled. It gave us 8 metres of 0.4 gold, 0.5% copper. So we investigated that result by drilling a hole, NC371, a fully cored triple tube hole, HQ, immediately on the side of GC1. And that gave us, it went down to 514 metres. It gave us 118 metres of 0.1% copper at the bottom of the hole. And that's a modest interval of low-grade mineralisation. I just put this up here. Mrs. Murphy was the driller's mother, because it's worth remembering that. So we drilled that hole. So we decided that was interesting and we better deepen it. So we deepened it to 858 metres, and Mrs. Murphy's son was still the driller, so he immediately went out of the mineralisation. But then deeper down, he got 102 metres of 0.1 gold and 0.4% copper. So his results were better and his luck might have been improving. And importantly, he hit a fault, and this fault is really important. So decision time. The negatives, deep in the section, low grade, 0.4% copper, narrow, 102 metres down hole. Positives, encouraging alteration. There was an alteration at Cadia called red rock, which is hematite dusting of the plagioclase feldspars, and that is significant. And we had improving grade. So the intuition was to drill additional holes. Now, the supporting evidence for the intuition was, this is the copper values down hole. These are 1 metre intervals. The red line is the fault. These are the gold values down hole. These are the copper equivalent values down hole. Now, the key elements of all that is A, the fault, B, these high spikes in copper and gold. They mean something. We didn't know what they meant, but we thought they meant something. So this is all the drilling that was done to discover Ridgeway. This is the fault. These green holes are the RC holes that were drilled. This is RC number 1. That was the indicator hole. These are purple holes are the holes that were drilled. So NC 371 was the first core hole we drilled with Mr. Murphy's son as the driller. So we drilled that hole. Then we drilled this hole, 484, and never went far enough. We drilled 485 was the second hole. It unfortunately went over the top of the fault, so that was a waste of time. The third hole out here had low-grade anomalous values in it. And logic would tell you if there was an ore body to be found, it obviously wasn't that way. It had to be this way. So that was the fourth hole, and that was the discovery hole. So I put this up. Discovery required drilling another 4 holes while holding one's nerve and thinking, because that was it all about. Whoops. So this just shows you a section. This discovery hole was projected 200 metres from the west. That's 498, which is the discovery hole. 145 metres at 4 grams per tonne gold, 1% copper, 84 at 7, 1.2% copper. Now, this is a really instructive section because it shows you how close to a Ridgeway deposit you can get without actually knowing it could be there, and you don't know it's there. So, and just to illustrate in more definition, this is a section by taking the discovery hole off. So that discovery was based on that sole intersection. And it's the reason why one needs to hold one's nerve when you're doing this sort of exploration. So this is the shape of the Cadia, the Ridgeway deposit. I mentioned the red rock. This is the red rock alteration boundary. So all this rock through here has red rock coloration in it. So this is holes coming from the other direction. You can see the grades are comparable to the hole 498. So that Ridgeway was mined as first a sub-level cave, then a block cave. And this is the substance zone of the cave zone in 2004. So discovery of KDF Far East deposit. Yeah, drilling for information as an exploration geologist is really important. What you need to always bear in mind as an exploration geologist, a drilling rig is only a very large geology hammer. It's a bit more expensive, but it really is only a large geology hammer. Once you can get yourself thinking this way, it's really easy to drill holes. And so it's okay to drill for geology because you're a geologist and you're trying to find something. So you need to know some geology. So Cadia Hill, Katiereese. Another thing in exploration is, back to that born drilling rig, that drilling rig can go to 1,500 metres core drilling. Wildcat drilling needs to be encouraged in exploration. Wildcat drilling means you just drill to find some knowledge. And so while Katiereese was being drilled here, curiosity got the better of us. And I've highlighted this hole NC 319, which is that. And so we drilled NC 319, which was our wildcat hole. When we'd finished it at 1,618 metres vertical depth, we had 1,618 metres of 0.61% copper equivalent, which isn't too bad. So this was the copper values down that hole. These are the gold values down the hole. So the copper grade down the hole averaged 0.25 copper basically. The gold averaged 0.1. If you have added them together with a bit of alchemy, you got 0.61 copper equivalent. Now, what did that result mean? This is the Cadia Hill deposit. This is the Katiereese deposit. This is the wildcat hole. So what did it mean? If you looked at it in terms of gold, we had high gold here, we had low gold here, we had low gold here, we had low gold here, we had a bit high gold. That's what we observed with the gold values. If we looked at the copper values, and the thing to bear in mind with copper is, if you look at Cadia Hill, the shape isn't the gold. So the high-grade gold, lower-grade gold that side. Copper, high-grade copper, lower-grade gold outside, copper outside. These faults are all reverse faults. So this block's coming up over that block, which is coming up over this block. So if we looked at copper and we observed that we had high copper in this part of Katiereese, we had low copper in this part of Katiereese, we had high copper in this part of Katiereese. We didn't know what was going down there, and we didn't know what was going down here. In this hole, we had high copper down here, and we had high copper at the end. So what did all that mean? In terms of geology, what we had was we had a flat-lying sequence of volcanics and volcaniclastic rocks, and nothing really of interest. You know, it was flat-lying, and that's what we expected. We had the Silurian, and we just had this layer cake volcanics, and this is our wildcat hole. When we look at the alteration, we had the strange phylic that didn't do what it should have been doing. It should have been plastered around the potassic zone. Instead, it decided to just go across the countryside following a lapilli tuff because it had higher permeability, and it was looking for permeability, so it followed permeability. This is a probiotic zone. This is potassic zone. This is the top of the vein zone. This is the top of the high-grade Katiereese deposit. Now, this was a great unknown, but it was probably potassic, which was interesting, because what was it doing down there and what did it mean? So in terms of gold observations, well, we knew we had plus 2 grams per tonne gold equivalent here. We knew all this in here was greater than a gram. We interpreted it was a gram down here. We had this deeper vein zone. We had this deeper bornite. And better say so. And, you know, they were trending this way. So the key to discovery is to observe and think. It's just science. There's nothing more to it. It's just science. You've got to observe and think. So this is what the observing we did with copper, and it wasn't rocket science. What we noted was the copper decreased as we went deeper. It increased as we went to the southeast, but we had higher copper in this hole, and was a possibility of higher copper on this side of the hole. This is a gold thinking. We had gold reduced that way. We had gold increased that way. We had an increased copper to gold ratio as we went down through here. We had a reduced copper to gold ratio as we headed down through here. But we had gold in this wildcat hole. So why wasn't the gold-copper ratio higher over here? That was the question we asked ourselves. So that became the target area. Now, this is where you're all going to throw your hands up and say, it's all smoke and mirrors, and I don't believe a word he's been telling me. So it came down to the what-if testing, which was hole 494, which was this hole. This is the Katiereese deposit. This is the Katiereese Hill deposit. So the what-if result, 494, we got 229 metres of 1.6 copper equivalent in an inclined hole. We had in this hole here, we had 1,000 metres, 1,600 metres of 0.61 copper equivalent in a vertical hole. Now, that's not a bad porphyry copper result. The Kalamazoo deposit at San Manuel in Arizona, which was developed in the late 1970s, had an average copper grade of 0.75% copper. So, you know, this is deep. But if you can get that and you've got roughly 1% copper equivalent, you might have something you can do something with. And that's where the hole went. Now, was it luck or good science? Yeah, it's yours to make. I like to think it was good science. So these are the Cadia deposits presently. This is Ridgeway. The geology is, these are the oldest rocks, the calcareous sediments of Weimala, overlain by forest reef volcanics, intruded by monzonites of different varieties and age. And so you've got Ridgeway, you've got Cadia Quarry, Cadia Hill, Katiereese, KDF Far East. And the Katiereese mine is the world's first super cave. The mining depth is up to 1,500 metres, probably 1,800 metres eventually. The ore is about 1 billion tonnes of 0.6% grams per tonne copper, 0.3 gold, and that's an equivalent grade of about 1% copper. These are individual panels, and this diagram's courtesy of Newcrest. So, conclusion, Newcrest gamble succeeded because it made its own luck. It rigged the odds, and it rigged the odds by employing talented explorers and letting them explore. It didn't tell them what to do. The Newcrest geologists were enabled to ask what if, and they're enabled to find out where. They could use a drilling rig to go and find the answer to the question, what if? Finally, and this isn't a discovery method that's probably taught in exploration management. Most people will throw you out, and an enlightened board helps. Thank you.
Thanks very much, Dan. That was a really insightful talk. Obviously, it's been a very protracted history for you working there, and it's great seeing the mine come into development as well as different phases. So thanks for that. Perhaps not as long as I thought you were going to talk for, Dan. You've got another half an hour if you wanted to.
Oh, I thought you'd want questions.
Embellish. Do we have any questions from the floor?
There's got to be questions.
We can also check online as well. No questions.
So how many people here have had anything to do with exploration? But you're all scientists. You're all explorers. That's what science is. It's a scientific method. So how would you think you normally do exploration? Do you follow a recipe, or what is it? How do you do science? If you're a metallurgist, how do you perform metallurgical science? You have an idea and you test it. It's a scientific method. That's all exploration is. I gave a talk 12 years ago or something in UWA and on exploration, and I had a PhD student come racing up afterwards, and he said, I never realised that exploration was research. And that's what it is. Exploration is a form of research. You just happen to have a lot more money to spend, and if you make a mess of it, you don't have a job. But that's what it is. And so once you can get that through your head, that's what you're doing. Somebody is willing to give you some money to go out and test your ideas. That's how you might end up being successful. There's no guarantee, but you could be. Yep.
With the benefit of hindsight, what additional exploration technologies that exist today might you have brought to bear?
None. I'm really old-fashioned. There's a grand old gentleman who's well in his 90s now called Sig Music. He was a man, he worked for John Paul Getty, Getty Oil and Exploration. And in the 1950s, he formed a company called Getty Exploration for Getty. And Sig was in charge of it. Sig trained as a B-29 bomber pilot in the Second World War. And so, but he's still alive. He's doing. But what he Sig in 1993 or something gave the talk in Denver, Colorado. There's a group called Greg's, was the Denver Regional Exploration Discussion Group or something. He gave a talk, and it was his. I can't remember the number, whether it was 13 or 19 canons for exploration. And they were all really simple things. You look for ore, not mineralisation. If you're going to find an ore deposit, you have to drill holes. And but some of his classics are, this was during the gold boom period. If you're looking for gold, the best pathfinder for gold is gold. If you're looking for copper, the best pathfinder for copper is copper. It's no more confusing than that. You just look for the mineral. And I've always followed that dictum, and that's how Newcrest have always, and that's how we explored in BHP and the part I was involved with. So keep it simple. And the trouble with technology, I'm not against technology. I think technology is great, but you need to know how to use it. I gave a talk a few years ago. There was an international geophysical conference in Melbourne, and for some reason they decided to ask me to give a keynote address. I thought, what the devil am I going to talk to them about? And I thought, well, I'll tell them they're all geochemists. So what I did was I gave them a talk about IP. And I said, IP was developed by Halloff from Newmont in the 1950s in the US to find the Arizona porphyry copper deposits, because they had pyrite in the halos like we used to find the Ridgeway. And so when you think about what IP does, it's a geochemical tool. What it is finding sulfur for you as sulfite. That's all it's doing. It doesn't, if you think it can tell you, it can't, in the 80s and 90s, there were different IP investigations to try and come out. Could you get a different IP effect from chalcopyrite to pyrite, RMIP? There were all these things, and it's mission impossible. If you just step back and say, what IP will do you is tell you this part of the world is better to look at than this part of the world. In 1974, I was working with BHP, and we're looking in Eastern Queensland for porphyries. A mate who was a geophysicist. When I started in BHP, we had to do our own IP. We didn't have enough geophysicists, so the geologists did their IP. They organised the surveys, they had them done, they interpreted the results. And we were looking for porphyries. And so I said to our mate, and said, what we're trying to do is actually find pyrite. If we can find pyrite, and then we can find some copper, we might find the porphyry copper deposit. So and you wouldn't be able to do it now, we strung this current electrode. I can't remember how many kilometres it went, but it had a 7.5 kVA generator. So we're banging a hell of a current in the ground. There was no protection for cattle. We just did it. Oh, this is being recorded, isn't it? Anyway, so we just walked around with a 300-metre dipole, and we basically did a Schlumberger depth sounding. And we were brilliant at finding IP. We did this around pyrite. We did this around the Mount Perry area. And so we can map out on kilometre scale IP, pyrite. There is a Chinaman Creek porphyry deposit there, sits within that. And there's probably other porphyries. Nobody's found an economic one yet. But you've got to look at technology in a different way. Don't look at it in the way the technologists necessarily want to sell it to you. there's a different application you can probably use. And IP is a classic. Don't use it as a geophysical technique. Use it as a geochemical technique that will find your sulphur. It won't find your copper, it'll find your sulphur. Anyway.
We've got a couple of questions online. One from Rob Chatterjee here at the SMI. He's interested in asking you to sort of elaborate on how constrained the modern explorationists are within listed companies by a more short-term kind of viewpoint from a company perspective.
So you've got a lawyer here. I really worry about modern exploration because what we did, I'm fairly old, what we did, you can't do anymore. And but there's probably ways around it. But somehow it's going to have to change because if you take a look at copper, we are going to consume as much copper in the next 20 years as the world has consumed in the last 3,000. And nobody is discovering those deposits. If you look at the deposits that exist at the moment in terms of the capital intensity, what it costs you to build a copper mine in terms of copper price, the capital intensity is 2 to 3 times the current copper price. So nobody's ever going to build the mines. So we're going to have to go out and find new mines that will I think we're going to go back to the past. It's back to the future sort of stuff. And people are probably going to have a look at higher grades in terms of copper. But how you do that within a modern mining company is beyond me. I couldn't work in a modern mining company anymore. Does that answer the question?
I expect so, yeah. It's going to be complicated. Just sort of going back to the days when you were given your initial challenge, there's a question here from Henry T-Bar, just wondering how the $20 per tonne initial board criteria was calculated, if you can...
Simply. If you went into a porphyry copper mine in the 70s and that, the mine geologist would show you a map and they didn't plot grade, they plotted dollars. So they had dollar boundaries because their cut-off grade, the cut-off grade in the mine, and there's a gentleman there that can tell you all about it. The cut-off grade in the mine is a dollar cut-off grade. Then in the end, it ends up as a dollar cut-off grade. So you might as well start. So if you back in 1990, $10 a rock. If you looked at the costs of mining, processing that, you had $10 rock and you had good recoveries. $10 was your cut-off. So if you had twice your cut-off, you're on the way to finding an ore body. That's how simple it was. And you can still do the same thing now. You should do the same thing now. You should always explore with using mineral economics and thinking about you're going to have to mine this thing, which means you need to know what metallurgists do, what mining engineers do, all sorts of other disciplines do.
I had a question for you, Dan, or sort of a little story that ends in a question. I remember standing in a creek bed with an assembled team of explorers and project reviewers. This is in Baja, California. The review team had flown over to review what we were doing on a porphyry project, and our porphyry expert, we were looking at a piece of rock that I think it was running, 0.3 or 0.4 copper, and having that person say to me as the porphyry expert, whatever you've got at the surface is what you're going to have at depth. So why do you think the grade is going to get better? And if you don't have a good answer, you should never drill a hole here. And to me, what you showed for Cadia is the exact opposite of that you should take that sort of grade as great encouragement. And you have no idea what the vertical change in copper grade is going to be.
Yeah, I agree totally. Newcrest explored in Halmaheras for epithermal gold deposits in Indonesia, but originally we were there looking for copper gold deposits, porphyry deposits, and there are a number of them there. They happen to be older only millions of years, but they're older than the epithermal gold. Now, you could walk around and sample the alteration on the surface, and it was potassic. It was secondary biotite, and it ran about 0.2% copper and 0.2 gold, but it was never going to make it in that environment. But we still drilled holes into it. Common sense would tell you that probably it won't get better, but it might. And what is interesting with that is one of the porphyries we drilled was Katiereese, and we intersected an epithermal vein in it that was eventually led to the discovery of the Katiereese gold deposit. So, there could be spin-offs, but never, the one hole, well, it's even worse than the one hole Harry syndrome. These companies that come in and drill one hole and they've solved the question. But I had a similar thing. Back in the late 60s, BHP had a relationship with an American company, and they had an expert, porphyry expert, and he came down and talked to us, and we were looking for porphyries in East Australia. And he knew a lot about Arizona and porphyries. But he said to us, you're just totally wasting your time looking for porphyries in Australia. The rocks are too old. And I said, well, what about, if you think about the history of the Paleozoic in Australia, most of it's been accumulation. We've been buried and now we're being exhumed. But no, it was just too old. And it's the same thing with your, if you got 0.3 or 0.4 on the surface and you haven't drilled a hole, you should be fired. That's what I'd do anyway. No, but that's part of the problem with exploration. That's why this whole emphasis is about thinking and taking risks, because that's what exploration is about. You've got to find a company that's willing to let you do that. Newcrest was really fortunate. They had John Quinn, who he was I remember him telling me when he was a kid, his father used to take him to the races. So he was he was into gambling, and that's what it is, and that's what Slichter said back in 1960. It is a gamble. It's a total gamble, but you're a professional gambler. You're not an average punter that's going to lose his money all the time. And so you got to work out how do you become a professional gambler. That's basically what it is.
Didn't you engage?
Just wait for argument.
Oh, don't worry. Didn't you engage?
This is 40 people online.
I'm sure I'm loud enough. Thanks. Dan, you would have engaged with the board, surely. Mm-hmm. You would have given them so in part, you weren't just lucky to have a board and John Quinn. You actively engaged with them and you provided them with what's really an evidence base, not just the models they may have been thinking of, but the evidence that you had on site. Is that what you did?
No.
No?
Well, we started off until we had the disaster in 96, 97 where Newcrest, and this cost John Quinn his job, they tried to take over Normandy mining because of rumours that were incorrect. And so we had a board up until then that was a BHP Newmont board. So the early days with that board wasn't easy because they were getting advice from America about how they should drill a porphyry. And but what you do as an exploration, particularly if you're in charge of it, you're going to live or die by what you succeed at. So forget about what they want. You just tell them what you're going to do, and then you do it. And if they want to fire you, they will fire. But if not, you'll sail through. So that's what we did. And Cadia Hill, by the time Cadia Hill was found, they thought, well, we must know what we're doing. And then we had a new board that came in that was a mining board. It had metallurgists that had mining engineers. So they were more attuned. And by then we had the runs on the board that I used to turn up at the budget meeting at the beginning of the year. And what I used to tell the Newcrest board is we need to spend around about $50 million a year. we need 50 million. During my time, we spent about $900 million on exploration. That's proving up and everything. And so what I said to them, we need to spend for at least 10 years. If you're going to measure us over 10 years, and we need to spend about $50 million a year. So what I'll do is I'll tell you at the start of the year how we're going to spend that $50 million. At the end of the year, I'll tell you how we actually spent it. And in between times, I'll give you progress scores. And that's all we did. So, but it's a set, and I don't know how you do it in a modern company now. Yeah, say a BHP or that. It's essential the exploration person relates directly to the board. He's got to go through the CEO, but the CEO will have his own agenda, and normally it's M&A and this sort of thing. If you're in there to discover, you've got to build a rapport with the board, and you've got to make them part of the team. That's what we did. We used to take the board on field trips and all sorts of things. So they had skin in the game. And it comes back to this whole gambling analogy. You're all part of the gamble, and they loved it. And the best word to use is encouraging. Occasionally you say, this is encouraging, and then keep going.
Just a question, I suppose, about the risk-taking you took when you were drilling. What do you think the chances were that you could have walked away from the district just like others had before you? Was that possible, or do you think you made the right choices? Obviously, you made the right choices to not walk away, but there were a couple of companies that obviously held the ground, scratched the surface and walked away. Going back to the model thinking, do you think that genetic models, you managed to go through a whole porphyry talk without showing a single Lowell and Gilbert or Silito model? Do we need those models? Do they help us, or did you make the right decisions based on results?
Look, there's a book that's here somewhere. The bloke, there's a book called The History of the Cadia Valley Mines, and it is really worth reading because it explains the philosophy, but the exploration philosophy as well as the mining philosophy. I grew up in porphyries in the late 60s, so I watched how all these models evolved, and I watched how people tried to use them as recipes. And so if you're exploring for porphyries, you need to understand what a porphyry, the basics of whatever a porphyry model is. But you need to think about a porphyry as a hydrothermal system that's impacted at enormous, square kilometres of ground, cubic kilometres of rock. So you need to think about that. And so what I did, and it's documented in this book, right at the outset, we had some great arguments, discussions with the geologist on site. They said, forget about everything you think you know, go and collect data, and then think about what the data might mean in terms of a hydrothermal system. But you don't actually know what the hydrothermal system has done in this part of the world. So that was one of the great failings. The Lowell and Gilbert model was a brilliant model. And, David Lowell found Kalamazoo using the Lowell and Gilbert model. That's how he found it. And because it was folded, and he found the down-folded part. That worked great in Arizona, southwest US. In the 1960s, the Kennecott geologists, Bear Creek was the great exploration research arm of Kennecott. So they knew more than anybody else in the world about exploring for porphyries in the southwest US. And but if you're looking for a porphyry in Papua New Guinea, it was a total waste of time, because porphyries, the mineral you look for in Papua New Guinea, if you're looking for a porphyry copper deposit, there's something called neotosite, which is a manganese wad. The manganese absorbs all these metals, and copper is one of those metals. And how you work, and neotosite is just a black, waxy-looking mineral. So you might see it on a fracture. So you get your geology pick, you you scrape a bit of it on your geology, you put some hydrochloric acid on it, and you find out the tip of your geology peak's got copper on it. That's how you explore for porphyry coppers in Papua New Guinea, southwest. So, if you came out of Arizona, you're looking for supergene leaching, you're looking for oxide, weathering, all this sort of stuff. And so, so the models are really good, but they're really dangerous unless you know what you're doing. And so I encourage people to think in terms of systems.
Let's have a quick follow on, because when you think of the historic mining that was going on at Cadia, it was small scale, but it was still there. It still kind of brought you to the region.
Oh, well, no, the iron ore mining at Cadia was major during the First and Second World War. Big Cadia was mined as an iron ore deposit. And, Australian Iron and Steel in the Blue Mountains, its ore came from Cadia. And, but, some of the, they were, the underground workings in Cadia, that they were very high grade veins. If you go back to Butte in Montana, Butte was originally a vein field. All the early mining until the early 1900s at Butte was veins. And it was the same at Cadia. It's the same history. And, what really got us in, or got me attracted to Cadia was that, I'd worked in Papua New Guinea in the 70s and that. And, BHP got into Octeti. Octeti, the Kennecott geologists found Octeti by finding the magnetite skarns in Okmenga and all these creeks. And you walk up and there's copper coming, the rocks are all blue. And so they, this is a really interesting story. They had found the skarns and they were drilling holes into them. 1968, Ken Phillips, who had found Panguna and had a falling out with CRA and left them and was consulting, he was made the exploration manager at Octeti. And so he was taken, Octeti was Mount Fuberlin. It was a 500-metre high hill. It had a geobotanical anomaly on it. There was no trees on the hill. It wasn't because they'd had agriculture. Nobody lived there. So it was an anomaly. You had all this jungle and this. So anyway, they took Ken up the top of the hill, and when you went there before it was mined, Octeti, all you saw was white clay and quartz veins. And if you sampled it, you got nothing because it was all leached. And so they took Ken up to it, and he said, "Oh, what's all this?" And it's useless, nothing in it. And he said, "Well, why don't we drill a hole?" So they drilled a vertical hole, and 70 metres down, they hit a perched supergene copper zone, and that's how Octeti was found. And no more complicated than that. The Kennecott people had found the skarns, and they were trying to make a mine out of the skarns. The skarns are high in fluorine, so you got a metallurgical problem to start with. And but Octeti's a great deposit, and that's how it was found. One man who just said drill a hole, and so he goes back to drilling holes.
When you, in terms of Cadia or anything similar to Cadia, is there so much data on permeability of the rocks, or when you were drilling?
Big one.
Permeability of the rocks?
Permeability, yeah, that's a really interesting. Yeah, that's a key. Yep.
Okay, good.
Yeah, okay. No, permeability.
Just.
That's okay.
Yeah.
You can go ahead,
No, you've really hit on a really important topic, and I think this is an important topic for people trying to find future porphyries. Don't think that porphyries all have to be veins. I can show you rocks from Cadia that go 4% copper, and there isn't a vein in it because they happen to be in those forestry volcanics that were sub-aerial or submarine. They were low down water. They weren't particularly indurated when the the system, well, Nathan probably knows more than I do, when the system impacted those rocks. And that's what happened to the phyllic zone. The phyllic zone at Cadia, instead of wrapping around the potassic, wraps around the top of it, but then it ran into this lapilli tuff, and it just goes horizontally across the countryside. And that cropped out, and you sample that, and you got nothing. There was nothing in the phyllic zone. But if it's near the Katiereese deposit, it's impacted by the veining and it's mineralised. The phyllic is mineralised there. Distally, it's not mineralised. So you need to think. So you really do need to think about permeability. Permeability is crucial. So the first thing when you go into an area, the first things you want to think about are faults. You know, what's the structural geology history? And there's probably no history because nobody's ever mapped them. They don't know what the movements have been on the faults. And that's crucial at Cadia. You know, you've probably got 2 kilometres of vertical displacement between these deposits over time, over 400 million years. Things are going up and down. Mostly it's west, well, it's the west block up over east. And so you need to know the structure, but then you need to know what are the host rocks. You know, if they're all intrusions, porphyries are essentially wall rock deposits. The wall rocks could be volcanics, they could be sediments, they could be intrusions. You know, Cadia Hill is a wall rock porphyry. It's a quartz monzonite porphyry that happened to be fractured and mineralised, but the porphyry is older than the mineralisation. So what you want to do when you look at it, when you go into an area, is look at the geology and what geology might be altered. And if you've got volcanics, what is the permeability, or what might have been the historical permeability? Because that can control the whole mineralisation thing. Yeah.
Okay. Big question for you now, Dan. What's the next discovery at Cadia likely to look like?
Oh, I think there's going to be more. My gut feeling is you've got to. What is really interesting, Cadia, there's this whole northwest trend, and there's a whole series. One of the faults is a thing called the PC fault, PC40 fault that cuts off Cadia, Big Cadia. If I was there now, we didn't do it, I would get up on top of somewhere Big Cadia and just drill a really deep hole, because maybe an angle hole, and see what happens under it. Because I think that there was a PhD done on Big Cadia, which it's a skarn. It's a calc-silic, it's a garnet skarn. And it did a really good job of linking the skarn formation to those monzonite intrusions. They came to the conclusion that the gold copper mineralisation at Big Cadia is related to the Cadia Hill quartz monzonite porphyry, which it can't be, because the quartz monzonite porphyry isn't related to the Cadia Hill mineralisation, because the Cadia Hill mineralisation is younger. So the skarn just happened to be a receptive rock. And if you look at the geochemistry of that, of the Big Cadia mineralisation, it's no different to the Cadia Hill geochemistry. So they're all part of the same thing. So you've got to ask yourself, what's under the Big Cadia skarn? And what's along that whole corridor? And the other thing I'd look at is, what are those alkaline intrusions? Because they mean something. These are alkalic porphyries, and alkalic alteration is important. Are those intrusions and dikes really dikes, or are they alteration corridors? Yeah. They could be totally barren, but they might tell you something.
And following the trend, the northwest southeast trend towards Goolies and further, do you think there's perspective around that way?
Yeah. And back that map, the regional geological, we had some really good geological mappers, and they did a really good job. That was mapped at 10,000 scale. And that zone of dikes outlines the whole Cadia district. Now, I don't know whether they've recorded all, you don't know where those dikes go under the basalt and that. But the other really interesting thing at Cadia is if you go up to Rowan Bray, there's a diatreme there that is a gold zinc diatreme. If you go to Montana tunnels in the US, the rocks there look exactly the same, which is a diatreme, look exactly the same as the Cadia diatreme, the Rowan Bray diatreme. So I think they'll be exploring there for years to come, and somebody's probably going to find a big deposit somewhere. That's my guess. Yeah.
That's good. Quite optimistic. Okay. Well, if there aren't any more questions from the floor, Dan, please stick around and have some tea. We can maybe ask you informally. But for now, I think if you could just join me in thanking Dan one more time for his great talk today. Thank you. I just want to take this opportunity just to advertise next week's talk. So this is on Friday the 3rd of September. We've got Matthew Nimmo and Andrew Miller from AMC, and they're going to be talking about geometallurgy modelling, the good, the bad and the ugly. So hopefully no case studies from Cadia coming in here. And also I just want one more plug for Anita's online tailings masterclass. There's still opportunity to register for this important masterclass. So please jump online and register if you can. Thanks very much, everyone.